Okay, so now we want to be able to graph exponential functions. So remember, exponential functions look like b to the x, or a times b to the x even. And some characteristics of an exponential function are that they're one-to-one. They have what's called a horizontal asymptote at y equals 0. So what you'll notice is that the graph gets really close to the x-axis, that line y equals 0, but it never touches it, okay? So that's what comes about with this. There are no x-intercepts there. So the graph gets really close to the y-axis but never touches it, so there's a horizontal asymptote there. The domain of both these functions goes from negative infinity to positive infinity. It goes forever to the left and forever to the right in both pictures, right? So negative infinity to positive infinity. The range, however, starts at 0 and goes up from there. So from 0 to infinity is our range. There is no x-intercepts. It never crosses that x-axis. There's a y-intercept at this point, 0, 1 here on both of them. If you change the number in the front, if you said a times b to the x, then the y-intercept would change. If b is bigger than 1, it's a growth, so it's increasing. If b is between 0 and 1, it's a decay, so it's decreasing. So this is b bigger than 1, growth. This is b less than 1, decay. So let's try to use that. For each of the following functions, graph it and state the domain, range, and asymptote. Okay, so this is 0.25 to the x. Because b is less than 1, this is a decay. So this guy is going to go down like that. It's going to be decaying. So the domain, remember, the domain never changes, negative infinity to positive infinity. The range, this guy still starts at 0 and goes to infinity. And then the asymptote is still at y equals 0, that x-axis there. Okay, 4 to the x. In this case, b is 4, so this is a growth. It still goes through 1 there. It just grows really fast, so it goes up really fast. But again, it still has all those same properties. Domain, negative infinity to infinity, range, 0 to infinity, and asymptote, y equals 0. So when will the domain, range, and asymptote change? Well, they'll change if you have transformations of your function, okay? So we talked about transformations a long time ago. Remember, when you add or subtract to the x, it shifts it horizontally. And when you add or subtract at the end, it shifts it vertically, okay? If we put a number in the front of that a in there, we could flip the graph over or not. So here's a function, 2 to the x plus 2 minus 3. So what we want to think about is, what does this plus 2 do, and what does that minus 3 do? Well, the plus 2 shifts to the left 2 units, and the minus 3 shifts down 3 units. So if you think about the regular graph, remember this is a b of 2, so it's a growth. Normally it would start here at 1 and look like that, okay? But I'm going to shift this guy around. I'm going to shift him left 2 and down 3. So everything shifts. This horizontal asymptote that was at y equals 0 is now going to be down here at y equals negative 3. It's still going to go up. It's still going to have the same shape, but I'm going to have a graph that looks like that now, okay? So let's answer some questions about it. What's the domain? Well, the domain didn't change, negative infinity to positive infinity. The range did change, though, because now the bottom of this function is at negative 3 instead of 0. So negative 3 to positive infinity. The asymptote is at y equals negative 3. The x and y intercepts, they're kind of hard to see from this picture. We'll use our graphing calculator to figure that out, so we'll do that in a second. Maximums and minimums, there are no maxes, there are no minimums. Remember, maximums look like this, minimums look like that. I don't have any of those in this shape. This guy is always increasing, so he's increasing from negative infinity to infinity, and that's because b in this case was 2. So it's never decreasing and it's never constant. So the only thing we have to get are the x-intercepts and y-intercepts. So let's put this equation in our graphing calculator, 2 to the x plus 2 minus 3, and see if we can get those pieces. 2 to the x plus, nope, to the x plus 2. I'm going to use parentheses around there so I ensure that all of that is in the exponent, minus 3. So here's my graph. I notice that the x-intercept is at negative 0.415 and the y-intercept is at 0, 1. So the x-intercept was at negative 0.415 and the y-intercept was at 1. So I didn't do a great job sketching this graph. Let's see if we can do a better job. It went more like that.